All right, in this video, we are going to take a look at a basic three-phase Y system and see how voltages and currents work. Whoops. This three-phase system is made up of a basic three-phase Y-connected generator and a three-phase Y-connected load. The first thing that we'll look at is how voltages work in this system. The generator supplies voltages to the load, and the load will draw current from the generator. So the supply that we have is a 120 208 volt supply. And whenever we have a Y system, we always have two voltages, what we call a phase voltage and a line voltage. So any three-phase Y system always has this. If we're looking at phase voltages for our load, the phase voltages happen between A and neutral, B and neutral, C and neutral. So voltage A to N is the voltage between A and neutral, and it is always the lower voltage of our supply. So the voltage from A to neutral is 120 volts. The voltage from B to neutral is 120 volts. And the voltage from C to neutral is 120 volts. So our phase voltages are always phase to neutral. Our line voltages are always between two lines. Line A and line B to line C, and line C to line A are our line voltages. So and they're always the higher voltage of our system. So VA to B is 208 volts. VB to C is 208 volts. And VC to A is 208 volts. And they are always, again, the higher voltage. And there are formulas that we use to find these line voltages. And they're probably not a bad idea to know what those formulas are. For line voltage VA to B, it's made up of, when we measure line voltage A to B, you can think of it as taking a voltmeter and connecting it from line A to line B. So if I had a voltmeter connected directly from line A to line B, it would read the voltage from phase A to N and then phase N to B, because it always reads the voltage from line A to line B. So our formula for line voltage A to B is V A to N, phase voltage VA to N, plus phase voltage VN to B. We go from A to N and N to B. The formula for voltage B to C, we think again of a voltmeter being connected from line B to line C, and it would read the voltage in one direction from line B through to the neutral, from the neutral through to line C. So voltage B to C is V B to N plus V N to C. Our last line voltage, VC to A, again is like putting a voltmeter from line C to line A, and it's reading the voltage in one direction from C to N and voltage N to A. So line voltage C to A is made up of phase voltage C to N plus phase voltage N to A. On pages 7, 8, and 9 in your module, it goes through how these line voltages, how you get the line voltages from the phase voltages, and how the line voltage will work out to 208 volts if the phase is 120. It goes through a bunch of math to show you how to do that. The one last thing I want to make a note of on this is there's a simple rule that we can use to go from the phase voltage to the line voltage. We can do all of the math on pages 7, 8, and 9 from our module to prove it, but in the end, line voltage will always equal phase voltage times the square root of 3. So that is what we call rule number 1 for Wye systems. And it's an important rule to remember. The line voltage will always equal the phase voltage times root 3. I think the one other thing I will mention here are common Wye voltages. Just write it out here. Common Wye system voltages. There are 3 common ones. I'm sure a number of you have probably heard of them. One of the most common is a 120 208 volt 120 208 volt Wye system. The second common one is oh my gosh. Yes. The second common one is 277 to 480 volt system. We don't see these systems as much in Canada. They're common in some parts of the United States. The third common Wye system voltage is 347 600 volts. Okay, now that we know what the voltages are on a 3-phase system, what the line and phase voltages are, we're going to take a look at where these voltages get put on a phasor diagram. And a phasor diagram is what we use to show where voltages are on my 3-phase system and where currents are on my 3-phase system. And for voltages, they're always displayed on the phasor diagram in the same way. There's a real standard way that we show all of the phase and line voltages for a Wye system. Figure 6 on page 5 in your ILM goes through where the phase voltages are located. At the 0 degree phasor, we deal with a 360 degree circle. At the 0 degree line, we always put phase voltage VA to N. 120 degrees, 120 degrees behind VA to N, we put phase voltage VB to N. And 120 degrees behind phase voltage B to N, we put phase voltage VC to N. And we always talk about, we always talk about, let's try that again. So those are the 3 phase voltages for the system. VA to N, always at 0 degrees. VB to N, always at 240 degrees. VC to N, always at 120 degrees. The phase voltages for these loads were 120 volts each. So I can also write on here, they're all 120 volts. Another thing to remember is that there's a specific phase sequence for these voltages. The previous module talks about positive phase sequence being, I got to get rid of this advertisement. Just give me a second. Thank you. The previous module talks about positive phase sequence being phase A followed by phase B followed by phase C. On a phasor diagram, we always think of our voltages rotating in a counterclockwise direction. We always think of our phases rotating in a counterclockwise direction. If I was standing at 0 degrees and phase A to N was the first phase that I saw, the next phase voltage I should see if it's positive phase sequence is phase B to N coming by here. So I would stand here, phase A to N would come by here, 120 degrees after that. Phase B to N would come by where I was standing, and 120 degrees after phase B to N, phase C to N would come by where I was standing. So for positive phase sequence, it's always A to N at 0, B to N at 240 degrees, C to N at 120 degrees. Another rule for Wye systems, we could call this rule number 2, is V line leads rule number 2 is V line leads V phase by 30 degrees. So if the line voltages lead the phase voltages by 30 degrees, I'll draw the line voltages on this phasor diagram. If the line voltages are VA to B, VB to C, VC to A, then line voltage AB leads phase voltage AN by 30 degrees. So I would draw the line voltage 30 degrees ahead of the phase voltage, VA to B. And it is 208 volts and leads phase voltage A to N by 30 degrees. For line voltage VB to C, here is VB to N. Line voltage VB to C would lead that by 30 degrees, so 30 degrees ahead of it, which puts line voltage B to C right here. VBC, which is 208 volts. The last line voltage, C to A, will lead phase voltage C to N by 30 degrees. So we would put VC to A right VC to A leads VC to N by 30 degrees ahead of it, and it is 208 volts. So that is where the voltages go on a standard Wye system. The phase voltages are always in the same place. The line voltages always lead those phase voltages by 30 degrees. For every system, balanced, unbalanced, that's where the voltages always go.